Well, we know that if you go back 30 years, carbon dioxide was less, quite a bit less 30 years ago. Methane was less quite a few 30 years ago. Nitrous oxide was less 30 years ago. So we know these gases are increasing with time.
Gases that affect the chemistry of the stratosphere, which is where the ozone layer exists that protects us from ultraviolet radiation.
So understanding the rate at which this stuff gets into the stratosphere and how it changes is extremely important to looking at the climate of the stratosphere and how the stratosphere climate affects the lower atmosphere.
So we really need to understand what controls the humidity of the stratosphere and actually be able to predict that in the future in order to improve the accuracy of our predictions of future climate change. And it turns out the most important place to go sample to understand that is the tropical upper troposphere, the top of the troposphere in the tropics. It's called the tropopause, which is actually a very high altitude, which is why we need a high altitude aircraft to study it.
So the tropical tropopause is at about 55,000 feet in the tropics. So if you go down to the equator, you have to go up quite high, above 50,000 feet. And the tropical tropopause is really important to the global atmosphere because most of the gases that get into the stratosphere, all the air that's circulating upward into the stratosphere goes through this tropical tropopause region.
So that's basically a gateway to the stratosphere. The general circulation transports air upward in the tropics, goes into the stratosphere, and then is spread throughout the stratosphere and comes down at the higher latitudes in the polar region.
And this is what ATREX is focused on, to look at that motion of air into the stratosphere and how the water is removed from that air as it rises upward.
We know a lot about it, but there are some puzzles about the details of how the clouds are formed and under what conditions they form. So that's probably the most important thing that we hope to gain from ATREX.
ATREX will address a number of really important issues. It'll give us a better understanding of exchange between the troposphere and the stratosphere and how that impacts atmospheric composition, how that affects the chemistry that goes on in the upper atmosphere, and in the longer term, how that will affect the climate.
And that will help us to understand as we go forward trying to figure out what to do about climate change to better predict it and make better decisions.
How does the interaction between the upper troposphere and the lower stratosphere affect us down below? How are we going to find out? We have the questions. Now we'll be searching for the answers. Hogs' sense of hearing is excellent, and their eyesight the best in the entire animal world. Not only can they see greater distances than humans, but their visual acuity is 8 times that of ours. Yet we need to look even further, higher, deeper into the sky.
We live in the lowest layer of the atmosphere, which is the troposphere. The stratosphere is the next layer above us, so it's basically above altitudes of somewhere between 30 and 50,000 feet.
There are processes that take place in the stratosphere that have very direct impact on us.
So it's extremely important to understand the detailed process of water turning into clouds, those particles in clouds settling out. How does that detailed process occur? And then how will it change in the future?
What's been our big problem is getting the airplanes to the right place where they can make the measurements for long enough periods of time to do the observations.